So, okay, now, so in the last class, I discussed about NumPy advantages or features. So in that we have seen NumPy array occupies less space or memory compared to the list data structures. And I said these are some of the points related to the list. In list, data is represented as objects, and objects are dynamic in size. The size of the object get increased dynamically based on the value, right? And this is when you have a huge amount of data, then list will occupy more space compared to which one? Array. So list object created with reference of objects found within the list. So it is like this. And every object is having type and so many properties, right? And this is what we have seen. And these are the points related to the so this is the points related with the NumPy array. In NumPy array, data is not represented as objects. NumPy array is an object in which data is represented as values, and it allocates memory only for values. Okay. Only values represented. It means all the data is represented as one object. It means all the data is represented as one object. But whereas a list contains number of objects. But here all the data is represented as how many objects? One object. All the data is represented as one object. But here in list you have a list object. In list you have a list object, and this list object doesn't have directly values. It is having address of what? Objects. It is having address of objects. Okay, so this occupies some space and this occupies some space. This occupies some space and this occupies some space. Because of that, the list occupies more space. But whereas in NumPy array, all the data is represented as one object. A NumPy array is having data types, and these data types define the size of memory allocated for each value, right? So this is what we have seen, like how it is been done when you're storing large amount of data. Second point is in array data is organized in continuous memory locations. In list, objects are stored arbitrarily or randomly. NumPy array takes less time to read data, but whereas list takes more time to iterate or read the data. Okay. So why list will take more time to iterate the data? Why list will take more time to iterate the data? Because the objects will not be stored and continuously. The objects are stored what here? Randomly. The objects will not be stored in continuous locations. The objects will get stored in what? Random locations. Because of that, see, heap is not sequential. Heap is what? Heap is not sequential. Heap is what? Dynamic. So objects are created dynamical. Objects are created what? Dynamical. It means now whenever you create a list, so what will happen is whenever you create a list, for example, I create a list with 10, 20, and what is that? 30. Now, if you take this is collection of, this is a memory. If you take this is a memory, okay, if you take this as a memory, and this is called as a RAM, or the same thing you call it as main memory. In main memory, which object is created? List object is created. In main memory, list object is created. Now, list is continuous, but list objects are what? Not continuous. List is continuous because list is which data structure? Sequential data structure. So list is a continuous, but list data is not continuous. Okay, list data is not continuous. So one object might be stored at this place. and one object might be stored at this place. One object might be stored at what? This place. And this is having different addresses. Now this is referring to this object, and this is referring to assume that this object, and this is referring to what? This object. Means the data is stored in sequential? No, the data is not in sequential. The data is what here? Random. So list is a linear, but list data is not linear. Okay, list is a linear, but list data is not linear. But when it comes to because of it is not linear, because of objects are not in linear, whenever you iterate, it should switch from one address to another address. It should switch from one address to another address. So that will take a lot of time when you have a huge amount of data and when you are retrieving it one by one. When you are retrieving it one by one. So when it comes to the array, when it comes to the array, I'm saying np.array. I'm creating an array with three elements, 10, 20, and 30. Three elements I've taken. So what will happen in NumPy array? Suppose if this is a memory, if this is a memory, and this is called as a main memory, this is called as a main memory, or this is called as RAM. So within the main memory, so array is created as one object. Now this is one object. This is one object, and this one object contain how many values? This one object contain how many values? Three values. So memory is a part of this object or outside the object? Part of this object. So there is a memory allocated for how many values? Three values. That is 10, 20, and what is that? 30. So this object is having some properties. If you see this properties, it is having a data type. It is having how many dimensions are there. Now these are other properties of what this object. This is which object here? This is which object here? Array object. This is which object here? Array object. So in array, data will be stored in which format? Continuous format. But whereas list data, list is a linear, but the data which is organized within the list is not linear. So the objects are created randomly within the main memory. The objects are created. Yes. Yes. So this is not efficient when you are reading large amount of data. So that is what we have seen in the last class. Okay. So list will be stored in the same order, sequential order, but whereas a list is a linear data structure. Okay, but data which is there inside the list is not linear. Data which is there in list is not linear. Okay. Then third point will say it. And what is the third point is? The third point is, so vectorization. Third point is vectorization. So third point is vectorization. Vector. So vector operations or vectorizations. Same thing. You can call it as vector operations or vectorization. Vector operations. Now, when it comes to vector means as a whenever you're talking about arrays, you can represent array as what? Vector. You can represent array as what? Vector, right? You can represent array as a vector. And vector operations doesn't support by the list. Vector operations doesn't supported by what? List. Vector operations means you want to operate, you want to perform certain operations directly on what? Array. You want to perform operations directly on what? Array. You want to perform certain operations. For example, when you are working with a list, for example, when you're working with a list, just here, I'm writing Jupyter notebook. So when you are working on the list, what will happen is you cannot apply certain operators. You cannot apply certain operations or operations directly. You cannot apply certain operations or operators directly. Okay. So what is the meaning of this? For example, you are working with a list. So list contain 1, 2, 3, 4, 5. So this list is having how many values? 5 values. Okay. Now I want to multiply each element of the list with some 2. I want to multiply each element of the list with what? 2. Then what will I do? I'll say B equal to A into what here? 2. Now this operations you call it as what? Vector operations. So vector means now you are applying operations on what? Complete list. Complete list. Okay, you want to apply the operations on the list. Now you want to perform some operations like what? Multiplying. I want to multiply each element of the list with what? 2. But what will happen? Will it multiply each element of the list with the 2? Will it multiply each element of the list with the 2? No, it doesn't multiply. But whenever you are using a star operator, what this star operator will do? Repetition. Will it do multiplication or repetition? Repetition. Star operator is used for what? Repetition, but not for multiplication. What will happen if I'm trying to say print A? So A is the original list and B is what? A list which repeat these elements how many times? 2 times. It will repeat these elements how many times? 2 times. But is it multiplied or repeated? Repeated. For example, I have a 2 matrices. Assume that, okay, assume that I have a 2 matrices. Okay, assume that I have a 2 matrices. One is A matrix with 1, 2 and 3 comma, what is it? 4. And there is a B matrix which is having 4, 5 comma, okay, 6 comma, what is it? 7. If I'm writing a C equal to A plus B, what plus operation is doing? What plus operation is doing? Adding or concatenating? Concatenating. Is it do addition or concatenation? Concatenation. But what I want to do it addition. I want to add these 2 matrices. But is it added these 2 matrices are concatenated? Concatenated. Means list doesn't support which operations? Vector operations. List doesn't support which operations? Vector operations. Means you cannot perform the operations. You cannot perform the operations directly on what? List. So whenever you are performing operations, it is trying to concatenate. It will try to what? Repeat. But when you work with the NumPy array, when you work with the NumPy array, suppose I create an array. Assume that there is a A1. A1 is an array. I'm just importing NumPy as what? NP. A equal to NP dot. What is the name of the function is? Array range 1 comma 4. 1 comma 4. Now this is called as which array? A array. Contain how many elements? 3 elements. Contain how many elements? 3 elements. And I want to multiply each element of the array with 2. I want to multiply each element of the array with what? 2. Now when I say print B, when I say print B, now you can see each element is multiplied with what? 2. Each element is multiplied with what? 2. So is it allowing vector operations? Yes. So you can apply certain operations on array or array elements. Array and what is that? Array elements. Okay. So that you can call it as vector operations. For example, I have another array. So I want to multiply these 2 arrays. I'm writing C equal to A into B. Okay, I'm saying C equal to A into B. When I'm saying C equal to A into B, and when I print C, now you can see, is it each element of the array is multiplied or not? Yes. That is 1 into 2 is a 2, 2, 4, 2 into 4 is 8, 3 into 6 is what? 18. In the same way, if I'm writing a D, okay, D equal to A plus B. So what will happen? It will add the elements of which one? Array. So 1 plus 2 is a 3, 2 plus 4 is a 6, 3 plus 6 is what? 9. But these operations are supported by the list? No. Vectorization or vector operations are not supported by what? List. But NumPy array support which operations? Vector operations. Means you can perform the operations on array and array elements by using certain operators. You can perform operations on array and array elements by using certain operators. That is supported by NumPy. But this is not supported by what? List. Understood? Okay. So this is one more advantage of using, yes, not only arithmetic operations, the operations which can be applied on array and array elements. Okay. You have a dot product, you have inversion, all these things you can do it. Bole. No, not required. NumPy, if you import once, that is enough. Okay. Right. That is in repetition in what list? Repetition in what list? But in array star is multiplying. Star means what here? Multiplying. In array, star means multiplying. Okay, in array, star means multiplying and plus means addition. Okay, and minus means subtraction. Okay, you can do division. So you can apply certain arithmetic operations on array and array elements. Array and array elements, but that you cannot do it when you are working with what? List. If I'm using a plus operator on plus operator on array, plus operator on list, what will it do? Concatenation. If I'm using a star, what it is do? A repetition. But what is my requirement? I want to multiply each element of the array with each element of what? Another. Okay, I want to add elements of one array with what? Elements of another array. How can I do all this? I cannot perform this programmatically. I have to write logic. Programmatically, I have to write lot of logic. So that can be avoided by simply using the predefined operators. Okay. So list doesn't support. So what is vector operations? First of all, you should know what is vector operations, vectorization or vector operations. What is vector operation is an operation which can be performed, an operation which can be performed, which can be performed on, which can be performed on, an operation which can be performed on array and array elements, array or array elements, array and array elements. Okay, is called vector operations. Array and array elements is called vector operations. So list, okay, list doesn't support, doesn't support which operations? Vector operations, vector operations. Okay. So here in list, okay, list plus operator, list plus operator, list plus operator performs what it performs? Concatenation, concatenation. Okay, list star operator performs what here? Repeating of elements, repeating of what? Elements, but doesn't support multiplying and what? Addition. Not only that, it doesn't support any other operators also. It doesn't support any other operators also, right? Okay. Admin Kavya, give the valid link. Okay. Give the valid link. Kavya, you're there, huh? Okay. Give the valid link. Link, Google, you have given some form link, right? Give the valid. Give as a link. Kavya, just give as a link. That is not working, it seems. Okay. It did copy paste in a browser. Okay. Not directly. Okay. Copy paste also not working. Okay. So NumPy, okay. So NumPy array support. Okay. Which operations? Vector operations. NumPy array support vector operations. Okay. So it allows to use certain operations. It allows to use certain operators. It allows to use some operators to perform, okay, on array and array elements. Array and what? Array elements are what? Values. So that you can call it as what here? Vectorization. That is called as a vectorization, right? So this is an example for list. So when you work with a list, it doesn't provide this, right? So what is the output of this? A repetition. The output of this is what? A repetition. So it is try to repeat the list elements number of times. And this is the another example. So this is a list to contain number of list. But when I'm using a plus operator, what plus is doing? Concatenation. But is it doing addition or concatenation? Concatenation. But I want to perform which operation? Addition. But when you are using NumPy, it allows which operations? Vector operations. Is it clear this one? Yes? Huh? So next one is, okay, next one is, now this is the output here. Okay. So next one is broadcasting. Okay, next one is broadcasting. NumPy is having a feature of broadcasting. Okay. NumPy is having a feature called which one? Broadcasting. Broadcasting. So which one here? Fourth one or third one? So third one is vector operations. And fourth one is broadcasting. Fourth one is what? Broadcasting. Casting means converting it from one type to another. Generally, you'll say converting it from one type to another. That you call it as what? Casting. I think in Python, while working with a Python, you learn typecasting. What is the meaning of typecasting? Converting of one object type to another type. Converting one object to another object is called typecasting or type conversion. Then what is a broadcasting? Casting means converting. Okay. Casting means what? Converting. Okay. Typecasting means converting of one object to type to another object. That you call it as which one? Typecasting. Then what is this broadcasting? Don't take a live streaming. Okay. Broadcast means live stream. Not that meaning. So what is a broadcasting? Converting all elements. It's not belongs to element types. It is not belongs to element types. For example, okay, I'll tell you a simple example. When you're working with a Python, you'll say 1 plus 1.5. What is the result you'll get? What is the result you get? 2.5. So when you're adding integer with a float, what is the result I'm getting? Float. Okay, so in integer and float, which one is a broader type? Which one is a broader type? Float. So integer is a narrow type and float is which type? A broader type. So whenever you do arithmetic operations on different data types, always you get the result in which type? A broader type. Always you get the result in which type? A broader type. Suppose if I'm writing 1 plus, okay, 1 plus 1.2 plus 1 plus 2j. Okay, 1 plus 1.2 plus 1 plus 2j. What is the result is? What is the result of this expression? 1 plus 1.2 is what? 2.2. And 2.2 plus 1 plus 2j becomes what? 3.2 plus 2j. So what is the result of this is? Complex. The result of this is what? Complex. But in this, how many data types are there? Three are there. One is integer, second is float, third is complex number. So when you're doing arithmetic operation on different types, you get always the result in which type? Broader type. In the same way, when you are working with array or when you are working with matrix, when you are working with array or when you are working with what? Matrix. Now you have a two matrices with different dimensions. You have a two matrices with what? Different dimensions, or you have a two arrays with a different dimensions. Now whenever you do certain operations, automatically it will do what? Broadcasting. Now as a programmer you can do the broadcasting. As a NumPy, automatically it will do which one? Broadcasting. Broadcasting is nothing but converting of one dimension to another dimension. Converting of one dimension to what? Another dimension. For example, you create 1D, you want to convert into what? 2D. Okay, now for that you don't require to create another array, array with what? 2D. Simply you can convert from 1D to what? 2D. Now that you can call it as which one? Broadcasting. So NumPy array, suppose you created one list. Assume that you created one list. List contains some four elements. Now this is 1D or 2D? 1D. Now I want to convert this into what? 2D. Then how can I convert? How can I convert? I cannot convert directly. What I have to do? I have to create another list. I have to create another list, and inside that list, I have to read the elements and I have to convert this into which one? Two dimension. So this is list with values. This is list with what? List. So it is having how many list here? Two lists. But this conversion is easy or difficult? Difficult. You have to write some code. You have to write some code to convert from one type to what? Another type. But when it comes to the NumPy, so converting of one dimension to another dimension, when you perform certain operations, is done what? Automatically. It is done what? Automatically. That you can call it as which one? Broadcasting. You have a separate topic on this one called broadcasting. You have a separate topic called which one? Broadcasting. Okay. NumPy broadcasting is there. Okay. NumPy, when you work with NumPy array broadcasting, see here. NumPy array broadcasting, see here. What you are doing it, you are trying to converting 1D to what? 2D, 2D to what? 3D. So broadcasting in NumPy is a mechanism that allows arithmetic operations to be performed on arrays of different shapes. But when you provide arithmetic operations on different shapes, it provides a way to vectorize array operations efficiently, avoiding explicit what? Python loops, and often leading to better performance. So how broadcasting work? When performing an operation between two arrays with different shapes, with different number of rows and columns, NumPy attempts to broadcast the smaller array across the larger one to make their shapes compatible. Compatible. But there are some rules and regulations. While doing the broadcasting, it follows certain rules and regulations. Understood? Right? It follows certain rules and regulations when it is converting from one shape to what? Another shape. When it is converting from one shape to another shape, it follows certain rules and regulations. Understood? Okay, so this conversion is done automatically. You don't require to do it. But when this broadcasting will be done, when you're performing some vector operations, when you're trying to perform some arithmetic operations on which one? Matrix. When you're performing arithmetic operations on array, when you're performing arithmetic operations on 1D array, a 2D array, a 3D array of different shapes, then automatically it will convert from one shape to another. So you don't require to think about that. So that process, you call it as which one? Broadcasting. Understood? What do you say here? Yes or no? Yes. Broadcasting is a process of converting. A shape is nothing but number of rows and columns. Converting a shape of shape of one array to what? Shape of one array to another, another, another what? Shape is called which one? Broadcasting. Broadcasting is a process of converting shape of one array to another shape. So that you can call it as which one? Broadcasting. So this broadcasting is done. Yes, this broadcasting is done. This broadcasting is done. This broadcasting, yeah, this broadcasting is done automatically, automatically, automatically when arithmetic operations performed automatically when arithmetic operations performed on different arrays with a different what? With the different shapes, different arrays with different shapes. So this broadcasting is done automatically when arithmetic operations performed on different arrays with different shapes. Different arrays with different shapes. So that you can call it as which one here? Broadcasting. Means as a developer, you don't think about what? Now when you multiply 2 into when you add a 2 by 2 matrix with 3 by 3 matrix, automatically you'll get the result in what? 3 by 3. So this broadcasting are two types. One is implicit and one more is what? Explicit. So NumPy support two types of broadcasting. One is implicit broadcasting, implicit broadcasting, and second one is explicit broadcasting. One is implicit broadcasting and one more is what? Explicit broadcasting. So type conversions also how many types? Two types. One is implicit and one more is explicit. Explicit means the thing which is done by the programmer. The thing which is done by the programmer is called what? Explicit. The thing which is done by the system is called what? Implicit. Implicit, explicit. Suppose if I'm writing 1 plus 1.5, what is the result is 2.5. Who's doing conversion? Are you doing conversion or done by the Python? Done by the Python. Anything is done by the Python runtime system. Okay, that you call it as which one? Implicit. But I want the result in integer. 1 plus 1.5, actually what is the result is 2.5. But I don't want the result in float. I want the result in what? Integer. I don't want the result in float. I want the result in what? Integer. Then what do you do it? So convert this result of expression from float to what? Integer. So this expression result is what? 2.5, and you converted 2.5 into what? Integer. This is implicit conversion or explicit? Explicit. This conversion you call it as which conversion? Explicit conversion. Polygon. So explicit means which is done by the programmer. Implicit means okay, implicit means it is done by the system. Explicit means it is done by the programmer. So NumPy supports both types of broadcasting, that is implicit broadcasting, and second one is what? Explicit broadcasting. But while doing broadcasting, you follow certain rules and regulations. That we'll see later. Okay, na? Yes. So is it clear this one? Broadcasting is clearer? Okay. Then how many things we have seen till now? Tell me, yaar, what is the first feature? क्या हुआ यार? What is the first feature? NumPy occupy less space. NumPy occupies less space. Second one is, what is the second one? हो गया NumPy? क्या हुआ यार? डेली आ रहे हैं आप लोग. Occupy less space. Second one is what? What is the second one? क्या हुआ यार? Address? What is the second feature? क्या हुआ यार? बोलो, first one is I said already. What is the first one? NumPy array occupies less space. कैसा occupy less space? How it occupies less space? Data is not represented as objects. Data is represented as what? Values. And NumPy array efficient in what? Reading. NumPy array efficient. It is efficient in if it is efficient in what? Reading. How it is efficient in reading? Because data is organized in which continuous locations. Data is organized in which locations? Continuous location. List is a linear data structure, but data is organized linear. No, data is not organized linear. When you iterate it, it takes a lot of time. But when you iterate it, it takes less time because the data is organized in which order? Sequential order. Continuous memory locations, but in list data will not be stored in continuous memory locations. Okay. So array is efficient in reading or iterating. Third one is what is the third one is vector operations. So NumPy array support which operations? Vector operations means you can perform certain operations on vector. Vector means array and array elements. Array and what? Array elements. You can use certain operators and array on array and array elements. That you call it as which operations? Vector operations. Next is what is the fourth one? Broadcasting. What is the fourth one is? Broadcasting. What is broadcasting? When you perform certain arithmetic operations on array or matrix, it will convert of different shapes. When you perform arithmetic operations on different shapes of matrix, then it will try to convert automatically from one shape to another shape. So as a programmer, you don't require to think about converting from one shape to another. It is done by whom? NumPy. So that you can call it as which one? Broadcasting. Understood? Understood or not? Okay. Then next is yes. Now when it comes to this, okay, when it comes, you have to remember because when you are learning NumPy, you should know why you are learning NumPy. Yes or no? When you are learning NumPy, you should know why you are learning NumPy. I said, no, there are a lot of features belongs to which one? NumPy. There are a lot of features belongs to what? NumPy. Say all these are features. First, efficient, okay, and support mathematical and statistical functions, support mathematical and statistical operations. I said vectorization, not required any loops to perform the operations. I said about broadcasting, okay, and memory efficiency because it will be stored in what? Continuous locations, right? All this you have to remember here. क्यों बोले तो आप array सीख रहे? अभी array, why you required an array? Is it list is array? List is array? No. List is a matrix? No. When you say matrix, you learn matrix in school, right? When you're saying matrix, matrix is having certain characteristics. As in matrix is having certain characteristics or not? Yes. It is having dimensions and all the things, right? Is it supported by a lister? What are the properties of lister? What are the properties of list? List is having only type. Okay, list is having a type. List looks like array, but it is not array. List looks like array, but it is not array. It doesn't have the characteristics of which one? Array. And list is heterogeneous. Okay, because it can hold a similar type of data or it can hold what? Different types of data. But when it comes to the array, you'll say what is array? Is a collection of similar type elements. It is a collection of similar type elements. Similar type means array contain only one type, but list contain what? Different types. The differences will see it. Okay, right? So next feature is, okay, support mathematical and statistical operations. I just take from here. So support, this support mathematical and statistical operations. Support mathematical and statistical operations. NumPy has a built-in functions for mathematics. That is, you are saying np.add, np.subtract, np.sin, np.exponent, np. What? Square roots. Statistical operations like np.mean, np.median, np.standard deviation, np. What? Variance. And it is also having a library which deals with which one? Linear algebra, np. Matrix, and np. Linear algebra inverse, np. Matrix multiplication, np. Solve, where you can solve linear equations. All this supported by which one? NumPy array. So NumPy is a package, and this package is having number of sub packages. This package is having number of sub packages. NumPy having sub packages. Sub packages means a package within the package is called which one? Sub package. If you take NumPy is a package, if you take that is where data science people like working with what? NumPy, because they don't write any code. If you go for data science, right? If you go for data science, you don't write much code. You'll try to use all functions. You try to use all the functions. You learn theoretically what is the formula behind that. You learn theoretically what is an algorithm used behind that. Okay, algorithm used behind that, the formula used behind that. That's it. But how you implement it, you don't write any code. You just use inbuilt functions. That's the reason non-technical person, he can easily understand data science and AI. So, but if you want to build your own functions and if you want to build an application compulsory, you should have a knowledge of Python. Understood? Right? So NumPy having sub packages. If you see the NumPy sub packages, there is a sub package called which one? Matrix. You find a sub package called Matrix. You open the official website of NumPy. You open official website of NumPy. Here you can see sub packages. numpy.org. So it is having number of sub packages. Now might be here you can see API reference. So this is underlying this one. Uh, Building from source. Where is this? In API reference only you can see here. Where is that module structure? You can see NumPy dot exceptions, NumPy dot Fourier transformation, NumPy dot which one? Linear algebra, NumPy dot which one? Polynomial, NumPy dot which one? Random, NumPy dot strings, NumPy dot testing, NumPy dot what? Typing. All these are which one? Sub packages. All these are sub packages. If we say NumPy dot linear algebra, see linear algebra. Now NumPy linear algebra functions. It depends on these two things. Okay, provide efficient low-level implementation of standard linear algebra algorithms. Okay, now you find a lot of functions in this. Now there is a at the rate. At the rate is for multiplying matrix. Okay, matrix and vector products. You have a dot linear algebra dot multiply dot, and you can see v dot. You have vector dot. Yeah, see all these are the functions belongs to which one? Linear algebra. So it is having number of sub packages. It is having number of sub packages. Now NumPy is the main package and it is having number of sub packages. Means it is providing a lot of functionality which can be used when you are working with scientific. Okay, when you are working with scientific and complex mathematical expressions, when you are working with images, when you are working with audio, when you are working with what? Video. All these sub packages are helpful. I'm just writing it here. So there is a NumPy is a main package and NumPy dot exceptions is what? Sub package. NumPy dot FFT is what? Sub package. NumPy dot linear algebra is what? Sub package. NumPy dot polynomial is what? Sub package. NumPy dot random. NumPy dot string. NumPy dot testing. NumPy dot what? Typing. NumPy dot matrix also there. No, in the list is not given, but NumPy dot matrix also there. NumPy dot matrix also there. Okay. So this is NumPy having sub packages. And whenever you are talking about modules, the modules makes it application development what? Easy. Matrix makes it, modules makes it application development is what? Easy. Because you don't require to write the predefined code. You are trying to use what? Existing code. Is it this is clear? Yes or no? Okay, support mathematical and what? Statistical operations. Support mathematical and statistical operations. Means you don't require to write the code. Everything is provided by what? NumPy. So NumPy has a built-in functions for mathematics, statistics, as well as what? Linear algebra. It is not only for mathematics, statistics, and linear algebra. It is also provide what? Random. It is also provide which one? Strings. It also providing which one? Typing. It is also provide testing. It is also provide polynomials, right? It provide lot of inbuilt functions where you can perform the operations related with mathematics, related with the statistics, related with what? Linear algebra. Is it clear? It means by providing these packages, by providing these packages, okay, programmer doesn't require to write code, write code. You want to multiply two matrices, you don't require to write lot of code. If it is a list, at least I have to write how many lines of code? Some 20 or 15 to 20 lines of code I have to write it for multiplying two matrices. But here you can do that by writing in how many lines? One line, because it is providing inbuilt or not. Yes. Is it list is having any operation called adding to list? No. Is it list is having any operation called subtracting two lists? No. Is it list is having any operation called multiplying two lists? No. It is not having any built-in functions. List is not having any built-in functions. Then what do you have to do? List is not having built-in functions. Then what do you have to do? You have to write your own. You have to write your own code. You have to write your own code to perform which operations? Vector operations or any other operations. But here, are you writing the code? Here, are you writing the code or using the code? Using the code because it is providing inbuilt functions. It is providing inbuilt function that is called as less coding. So by providing these packages, programmer doesn't require to write code. Okay, programmer try to use which code? Existing code. Existing. Okay, existing code, right? So application development becomes what? Easy. Application development becomes what? Easy, right? So this is another feature. Support mathematical and statistical operations. The next one is it is an API. It is an API. Sixth one is it is an API, which is nothing but application programming interface. When I'm saying it is application programming interface, okay, now it is a base. It is a base for developing other NumPy libraries. Now this allows you to build other NumPy libraries, or it is a base, or it define some set of rules and regulations for developing NumPy libraries. And there is an interoperability, means this library can be used by other libraries belongs to what? Data science and AI. So when you are working with pandas, so pandas uses what? NumPy. When you are working with TensorFlow, TensorFlow uses what? NumPy. If you are working with Keras, Keras uses what again? NumPy. So there is an interoperability, means this NumPy can be used in any other libraries, irrespective of what? Irrespective of the content, what it is used, it can be moved from one library to another. So there are so many dependencies. There are so many dependent libraries which uses which library? NumPy library. Ring or not. So it is an API reference. Next feature is API reference. API reference. What is the meaning of API reference? Okay, what is the meaning of API reference here? Are you getting or not? All of you, right? So I'm going slow because it's a new topic, right? Okay, but once we enter into the coding part, I'll make it little bit fast so that we can complete within the time. Okay, na? Otherwise, you'll think that sir is taking more time only in introduction. सही है गलत है? नहीं है? सही है? नो नो बोले तो गलत है, सही है? यू आर सेइंग नो, ऐसे जाना. दिस इज ओके. यू वांट फास्ट? नो. फिर बाद में बोलते हैं यार आप लोग ये सर स्लो पढ़ा रहे बोल के. Because every Python developer must know AI, artificial intelligence, right? So AI is compulsory, it is becoming, right? Day-to-day life for software people, because uh, software companies, okay, they are telling the people, developers use what? AI. Why they are saying use AI? Because their work becomes what? Easy and efficient, fast. Huh? So compulsory AI का जरूरी पड़ेगा आपको. So you are using AI. Now by learning this NumPy, Pandas, Matplotlib, you can build AI applications, and you can also become a data analytics or business analyst. Okay, na? Suppose you completed NumPy, Pandas, and Matplotlib. Then what do you learn next? Power BI. What do you learn next? Tableau. You already know database, right? Power BI, Tableau, and Excel. Now you become which one? Data analyst. You are eligible to attend to apply which job? Data analyst. So how to learn Power BI? These are tools. You don't require to write the code. Okay, now these are tools. You don't require to write the code. MS Excel, you know Excel? Huh? The Excel what you learn in school is different. Huh? Okay, school, Kali, you type the data and drag and drop, move it from one place to another place, delete it, but you don't do anything, right? Are you doing any analysis in Excel? Huh? No. You just put some data and draw the graph, खुश हो जाते. But why that chart is what you get from that chart, what insights you get from that chart, you don't know that, right? So, but as a business analyst, you try to draw the chart based on what insight, what is the output you'll get. Understood, right? So the next feature what you have is API reference. It means NumPy API provides set of rules and regulations which allows you to develop other NumPy array related libraries. NumPy array related libraries, right? So NumPy API provides set of rules and regulations for building other NumPy array related libraries. Now, when you see this, just go to where you find all these libraries in. Tell me, yaar, where you find all these libraries in? कहाँ पे रहता है यार? pypi.org. pypi.org. What is pypi? Not a number. Python package index. Python package index. What is the name of the library? NumPy. NumPy बोल के type करो. How many libraries you are getting here? कितने हैं देखो इधर. ये पूरा किसका libraries है? NumPy related. So there is a NumPy. What is a NumPy is? Julia NumPy. Okay. So can you, sir, can you use English only, please? Okay. Okay, I'll use English only. Okay. Hindi, you don't understand. Some people, yes, no Hindi. Okay. Sunil, Surya, Suri is there. Uh, Suppose you got a job in Pune. You got a job in Pune. क्या करना है? What do you do? In Pune, Telugu people will be there. Who will be there? Marathi. Not Hindi also. Huh? Marathi. You are from Sydney. Okay. You are Telugu. You are Telugu guy or English? తెలుగు తెలుగులో మాట్లాడవచ్చా మరి? You are in Sydney and you must know it Hindi. No Hindi. Okay. You have a NumPy cloud. See, this is all these things are customized. I mean, these are customized NumPy libraries. And all these libraries are developed by using which reference? NumPy API reference. So NumPy API provides set of rules and regulations for building other NumPy related libraries. Okay. The next one is interoperability. Next one is what? Interoperability. Okay. So what is the meaning of interoperability? What is the meaning of this interoperability, means? What is the meaning of interoperability? Yes. Interoperability. Broadcasting. What is interoperability? Between. So sixth one is sixth or seventh? Seventh. Interoperability. So what is interoperability? One of the advantages of certain languages, you'll say interoperability. For example, you are working with, suppose when you are working with REST API, REST APIs are what? Interoperable. Interoperable means that will work with one language or any language. That will work with one language or any language. Any language. Okay, that can access by any language. That you can call it as which one? Interoperability. But when you are talking about interoperability of NumPy, this NumPy is used by so many libraries. This NumPy is used by so many libraries. Belongs to what? Python. Means there are a lot of dependencies. For example, pandas is there. Pandas work on the top of which one? NumPy. Okay, if you are talking about keras, the keras will work on the top of which one? NumPy. So it means what is the basic data structure for pandas and keras are TensorFlow? NumPy only. So that you can call it as which one? Interoperability. NumPy interoperability, it allows use this functionality between different libraries provided by which one? Provided by Python. Provided by which one? Python. So interoperability. So I'm just writing here interoperability. See here, NumPy interoperability. So what is NumPy interoperability? Refers to ability of NumPy arrays and functions can interact with what? Other Python libraries and data structures. Particularly those are designed for numerical computing and data science. This interoperability crucial for building complex data pipelines and leveraging the strengths of different tools within the Python ecosystem. That is what I say, no? NumPy is used by pandas. NumPy is used by SciPy. NumPy is used by what? Keras. NumPy used by which one? Scikit-learn. All these libraries depends on which one? NumPy. So that you can call it as which one? Interoperability. It means between different libraries. It means these functions can be exchanged between different libraries. So that you can call it as which one? Interoperacy here. Integration with other libraries. What is that libraries? Pandas. Okay, QPy. And what is this? PyTorch or what is that? TensorFlow. What is this? SciPy and other visualization libraries. So interoperability, yeah, is it clear? Yes. Interoperability so allows to integrate NumPy with other what? Libraries. Allows to integrate NumPy with other libraries. So that you can call it as interoperability. So this definition, okay, this definition I take it, don't mind. Okay, I take this definition here, okay, for your reference purpose. But first line is my definition and this is Google definition, but both are same. So NumPy interoperability refers to the ability of NumPy array and functions to interact with other Python libraries and data structures, particularly those designed for numerical computing or data science. So this interoperability is a crucial for building complex data pipelines, leveraging the strengths of different tools with within the Python ecosystem. And means these are the libraries. These are the libraries. Integration with other libraries. Okay, integration with other libraries. Integration with other libraries. Integration with other libraries. Like there is a library called which one? Pandas. Okay, there is a library called SciPy. There is a library called TensorFlow. There is a library called TensorFlow. There is a library called Keras. There is a library called Keras, right? And other data visualization, other data visualization tools. It means this work with other libraries, and that you can call it as which one? Interoperability. Understood? Right? Now tell me here, what is the first feature is? Less space. NumPy array occupies less space. Second one is efficient. Efficient. Efficient what? Reading. Efficient in reading or iterating. What is the third one? Uh, Vector operation. What is the third one? Vector operation. What is the fourth one? Broadcasting. Fourth one is what? Broadcasting. What is the fifth one? Inbuilt. Inbuilt what? Inbuilt. Inbuilt what? Functions. Inbuilt functions. What is the sixth one? API reference. Okay, then what is the seventh one? Interoperability. Interoperability. Right? This is a next feature. Understood all these features? Seven we have seen. What is the first one? Less space. What is the second one? Efficient reading. What is the third one? Vector operations. What is the fourth one? Broadcasting. What is the fifth one? Inbuilt functions. What is the sixth one? API reference. What is the seventh one? Interoperability. So what is the NumPy? Library. What is NumPy? Library. Provide one powerful data structure. NumPy is a library which provide one powerful data structure. What is that data structure? ND array. ND array represents what? Array. Array can be 1D, array can be 2D, array can be 3D. By representing data in 1D, 2D and 3D, you can perform some mathematical operations, you can perform some statistical operations. Understood? Numerical analysis, scientific analysis. All this you can do it by organizing the data in the form of rows and columns. Clear? Okay, then you have some more features, but we'll discuss that. Not today, but in the next class, we'll see it. Next class means, now tomorrow onwards, you don't have classes. Okay, so next class will be there on when you're Monday. Next class will be on Monday. Online students, okay, next class will be there on Monday. Okay, next class is on Monday. There's no class tomorrow. Next class will be on Monday, right? Yes, thank you. We'll see you on Monday. Happy Dasra. Happy Dasra. Next class will be there on Monday, right? Thank you. Right. Yeah, 6th October. Right. Happy Dasra. We'll see you on Monday, right? Thank you.